For analyzing the circuits with capacitor, we generally use Kirchhoff's law. And while applying the Kirchhoff's law, when number of the unknown variable become more than 2, we need to write 3 or more equations, that is the loop equations. For finding the unknowns, we need to solve 3 or more equations in this case. The process becomes lengthy and time consuming. Also, the chances of calculation mistake are common. For avoiding the lengthy process, there is a very smart method, that is the nodal method of analysis of the capacitor circuit. Let us learn this method. In fact, nodal analysis is based on conservation of the charge. We learn in the Kirchhoff's junction rule, incoming charge should be equal to outgoing charge. So in this case, that is the nodal analysis, we can say for any isolated region, the circuit charge should be conserved. So let us first learn what is the meaning of the isolated region. So we are making one circuit diagram here. You can observe this circuit is having the 5 capacitors C1, C2, C3, C4 and C5. You can observe here these plates, that is the right plate of C1, left plate of C2 and upper plate of C5 are not connected with elsewhere of this circuit or any outer point of the circuit. That means they are isolated, they are connected together. So here we can say this system of 3 plates are forming the isolated system, these 3 plates. So we call this isolated system. Now observe these 3 plates, that is the lower plate of C5, right plate of C3, left plate of C4. They are again, you can observe, they are not connected elsewhere from the circuit. We can say these 3 plates again are forming the isolated system, right? This is isolated system. Now we know what is the meaning of isolated system. Also we know conservation of the charge for isolated system, that is charge should be conserved for the isolated system. Now let us learn the problem solving steps. Step number 1. Mark the different nodes in the circuit and assign their potential. In any circuit, mark different nodes and assign potential of the circuit. For this purpose, you should start from one node and call this node as a reference node and assign the potential of that node equal to 0 volt and write the corresponding potential of other point. Now step number 2, identify the isolated systems in the circuit and write the equation of conservation of the charge for the circuit. After doing so, we will have the sufficient equations for getting the unknown value. Now third step is nothing but solving the equation. These are 3 simple steps. You can say 2 simple steps. Now let us learn this method through some illustration. We are having the 5 capacitors and 1 battery. The EMF of the battery, you can say, that is E, and we need to find the potential difference across the capacitor C5. We can solve this problem using the Kirchhoff's law also. But if we use the Kirchhoff's law, we may need to solve many equations and process become lengthy. So here we will learn how to solve this problem by using the nodal analysis. Now remember what was the step number 1. In step number 1, there was mark different nodes in the circuit and assign their potential, right? So now let us write step number 1, that is mark different node of the circuit and assign their potential. Here we need to do one thing. As we discussed, we need to assign one node as a reference node and we need to write that reference node as a 0 volt. So it will be easy to make this point as a reference node and write the potential of this node as 0 volt. Now you can observe the EMF of this battery is E, that is the potential difference across this battery is E, and we have assigned 0 volt for the negative plate. Then we can write E as a potential of this point, that is the potential difference across the battery also. So this is E. Now you can observe this wire is not having any circuit element, that is battery, resistance or capacitor. That means potential of all points, that is potential of this point and this point should also be 0. Okay, 0 and 0. Now come to this point. We have written potential of this point is E. It means the potential of this point is also E, potential of this point is also E, and potential of this point should also be E. So we can write here E, and here we can also write E. Now we cannot write directly any value for potential of this point and this point. So let us make these 2 points as unknown. Then let us assign the potential of this node as X and potential of this node as Y, right? And here we need to find X minus Y, that is we need to find the value of X or Y, or you can say we need to find the value of X minus Y. Come to the step number 2. In step number 2, what was the process? Process was identify the isolated system in the circuit and write the equation of conservation of charges. So before conserving the charge, let us find the charge on different plates of the capacitor, or you can say charge of the capacitor. Now we know the potential difference across each capacitor. You can observe the potential difference across this capacitor is E minus X if we consider E is greater than X. So we can say this will be the positive plate, this will be negative plate. So potential difference will be equal to E minus X. Here you can say potential difference if we consider E is greater than Y, then potential difference across this will be equal to E minus Y. Similarly, you can say potential difference across this capacitor is X minus Y. Potential difference across this capacitor is X minus 0, that is X. Potential difference across C4 should be equal to Y minus 0 equal to Y. So let us write the charge of this capacitor. We know the formula Q equal to CV. So Q1 should be equal to C1 multiplied by potential difference, that is equal to E minus X. So Q1 equal to C1 multiplication E minus X. That is the charge of this capacitor. And here we considered this plate as positive. So this plate will be negative. Now come to this capacitor. This is charged, say Q2, and this Q2 equal to capacitance multiplied by potential difference equal to X minus 0. So Q2 equal to C2 multiplied by X minus 0. Now come to the capacitor C3. C3 is having the potential difference E minus Y and capacitance is C3. So Q3 equal to C3 multiplication E minus Y, right? This is the charge of this capacitor. Now similar way we can write C4, that is Q4 equal to C4 multiplied by Y minus 0. So this is the charge on the Q4, and in this same fashion we can write the charge of this, that equal to Q5 equal to C5 multiplied by X minus Y. These are the charge on the different capacitors. And let us identify the positive and negative plate. This is positive plate, this should be negative plate because we assigned E is greater than X. We can assume here because we don't know the value of X, that's why we assign some value that is less than E. So this is positive plate, this is negative plate. And here we can say this will be the positive plate, this will be negative plate, and here you can say this will be positive and this is negative plate. Now we can identify the isolated system as we discuss. We can observe these 3 plates are forming the isolated system. That means summation of the charge enclosed in the isolated system should be 0. So this is negative plate, that is minus Q1 plus Q2 plus Q5 equal to 0. This is the equation for the isolated system, that is minus Q1 plus Q2 plus Q5 equal to 0, correct? Now you can observe here also, this is another isolated system. That means summation of these charges, the charge of these plates should also be 0. So here we can say this is the negative plate, this is the positive plate, and this is the negative plate. So here we can write Q4 minus Q3 minus Q5 equal to 0. This is the conservation of the charge for this isolated system. Now we know the value of Q1, Q2 and Q3. If we substitute the value of Q1, Q2 and Q3 in this equation and this equation, we will get two equations because we have the two unknowns here. So here step number 3 is nothing but solving the equation. So the first equation is this, that is minus Q1 plus Q2 plus Q5, and this value is Q1, this is Q2, this is Q5, we can write. And we know the summation of the charge for isolated system should be 0. So we are getting one equation, that is the equation number 1. This is the equation number 1 for this isolated system, that is the upper isolated system. We can observe there are two unknowns. Now let us substitute the value of Q4, Q3 and Q5 in this equation. We know the value of Q4 here, this is Q3 and this is Q5. So we can substitute the value this. Now we can observe here two unknowns and here also two unknowns. Now we are getting the two linear equation and two variable which are unknowns. We can easily solve these variable to get the value of x minus y. So we can get the value of potential difference across the capacitor C5, right? So this was the theory part of the nodal system. Now let us take one illustration for consolidation of the concept. So let us take one circuit here. You can observe here there are two batteries, 10 volt and 20 volt, and three capacitors C1, C2 and C3, right? And here we need to find the charge on each capacitor. Again, we can say we can solve this problem by using the Kirchhoff's equations, loop equation and junction law. And here we are going to solve this equation using the nodal method. So let us make this circuit again. And first step for solving the problem is, let us assume one point as a node, that is the reference node. So we can take any of the point as a node. Let us take this point as a reference node, A point. Let us call this point is A and reference node, and write the potential of this node as 0 volt. Now we fix the potential of A. Now let us write the potentials of other point, keeping the potential of the reference node at 0 volt. If we observe there is a battery of 20 volt, this is the negative plate, this is the positive plate, that is potential difference across this battery equal to 20 volt. If we assume this as 0, that means we need to consider this point as a 20 volt. So this point we need to write 20 volt. Now let us move further and write the potential of other point. We cannot now write the potential of this point directly. We cannot write potential of this again as 0 because we have referred this point as 0 volt. So we need to write the potential of this point as an unknown. Let us call this point as B and write the potential of this point is x volt. You can observe this battery is having the potential difference 10 volt. Then we assign the potential of this point as x volt. That means the potential of this point should also be x volt because no any other circuit element is connected across these two junctions. So this is also x volt. Now come to this point. Now this battery is having the potential difference 10 volt. Here we cannot write potential of negative plate as 0 volt because here we assigned reference point as 0 volt and B point, that is the negative terminal of this battery, as X volt. That is, we need to write the potential of this point equal to X plus 10 volt. So this is X plus 10 volt, right? Now we can observe no any other circuit element is connected across these 2 points. So potential of this point should also be X plus 10 volt, right? Now we assign the potential of each and every node or junction, right? Now it is time to find the charge on plates of each capacitors. Now let us start from capacitor C1. We can observe the potential of this point is 20 and this is X. That is, potential difference across this capacitor is 20 minus X, and capacitance is 2 microfarad. That means the charge on this capacitor should be equal to 2 multiplied by 20 minus X microcoulomb, and this will be positive and this will be negative plate. So charge on this plate should be equal to 2 multiplied by 20 minus X, correct? Now come to this capacitor. We assume this 0, this X, let us consider X is greater than 0, this will be positive plate and this will be negative plate. Now the potential difference across this capacitor is X minus 0 and capacitance of this capacitor is 4. So charge on this plate should be equal to 4 multiplied by X minus 0. And now come to this capacitor. The potential of this plate should be equal to X plus 10 volt and this is 0. That means this should be positive plate and charge on this plate should be equal to 2 multiplied by X plus 10. Now we can observe these enclosed area is forming an isolated system. You can observe here one battery, that is 20 volt, is enclosed within the isolated system. We can enclose any of the battery in the isolated system because battery is not a generator of the charge. It is just a charge pump. So we can include the battery inside our isolated system, right? And in any isolated system, we know conservation of the charge is valid. So we need to add the charge of this plate and this plate. That is a positive plate, negative plate and negative plate, and sum should be equal to 0. So let us make this circuit diagram again. This is the isolated system as we discussed. So let us make this circuit diagram again and write the charge of this. That is positive charge. This is 2 multiplied by 20 minus X. This is a negative charge, that is 4 multiplied by X minus 0 with negative sign, and here we can observe again negative charge equal to 2 multiplied by X plus 10, and summation of these charges should be equal to 0. You can observe now we need to solve only one variable, that is X. If we solve this equation, we get the equation simplified equal to 20 minus 8X equal to 0. If we solve this equation for X, we get the value of X equal to 20 divided by 8, and this 20 divided by 8 should be equal to 5 by 2. That is 2.5 volt. Now if we substitute the value of X in this equation and this equation, we can find the charges on all capacitor, right? So let us find the charge of this. You can observe here X equal to 2.5, that is 12.5 multiplied by 2, that equal to 25 microcoulomb. Now come to this. This equal to, you can observe 2 multiplied by 17.5, that should be equal to 35 microcoulomb, and here you can observe this is 4 multiplied by 2.5, that equal to 10 microcoulomb, and this is 35 microcoulomb. These are the charges on different capacitors.
Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.